Hello guys, today we're going to be using a BCA table like we learned in the last video to determine the limiting and excess reactants. First we have a couple steps written down here, like 1, determine the mole ratio from the balanced equation, then 2, determine the mole ratio formed with the actual mole amount, then the arrow. If the actual amount is less than the required mole ratio, the numerator is the limiting reactant. If the actual ratio is greater than the required mole ratio, the denominator is the limiting reactant. But I can do it a little bit differently. Like here we have this 4NH3 plus 5O2 yields to 4NO plus 6H2O. Question is, if a container initially has 10 molecules of O2 and 10 molecules of NH3, how many total molecules, reactants, and products would be present after the reaction goes to completion? So it's a simple BCA table. BCA. You have 10 molic here, 10 molic here, dots, and 0 molic here, and 0 molic here. What I do to determine it is a little bit different. Like, I pretend that these are a 1-to-1 ratio. So I do like the amount of moles or molecules, divide that by 4 to get it. So like 10 divided by 4 is pretend 2.5, I believe, and 10 divided by 5 is 2. So since this one is less than that, this would, would be excess. Then this one would just be limiting. And after that, it's just a simple BCA table. So minus, since this is excess, 10 times that by 4 over 5 equals 8. So 2 molecules left over there. And then here, it's just simple minus 10 molic, 0 molic. Here, don't make a mistake, since you know this is limiting, you'll only be using that. So minus, now add that to 10, 4 over 5 equals 8 molecules. There, now add that to 10, 6 over 5 equals 12 molecules. Then it's asking how many total molecules would be total. So what you do is 2 molecules there, plus 0 there, plus 8 there, plus 12 there. So 20 plus 2. So 22 total molecules. Basically, a BCA table is easy, and there's many ways to do it, but that's how I do it with like the division and stuff.